So, thank you very much. This is the work upon preserving privacy using multi-party computation for data analytics in the ecosystem provided by the IoT, Internet of Things, Fog and Edge Cloud ecosystem. This is a joint work with the group of the Universidad de la Frontera, with Samuel Sepúlveda and myself, and the group in the UNICAMP, Brazil, with Luiz Fernando Bittencourt and Fabio Moreira Costa from the Universidad Federal de Goiás, and Nikolaos Georgantas from the INRE Paris. I will show you the main concepts of our proposal, and then how we intend to tackle with the architectural principles, which is, I can tell you this now, is bring the privacy close to the edge, close to the IoT side. And then we have in mind some applications which I'll present in the pilot and validation. And okay, so when we think about the IoT, the standard security IoT, the main assumption everybody does is that the computations by using the gathered data from the IoT is transported to the trusted server, external trusted server, using secure sessions. But this needs, of course, lots of computational power. The IoT side has low computational capabilities, so more often than not, they cannot use their own architecture for performing, say, cryptography, adequate cryptography. It has to be user-friendly, and it has to provide the necessary security. But okay, this most of the time at the IoT side, the equipment which is being used is using the standard encoded encryption processes, which is more a coding, but by using the defaults. On the other hand, we need confidentiality and integrity of the data that should not be changed by, say, a man in the middle, and provided authenticity and authentication. The CIA, usual CIA, but also the notions included in the Parker Hexat, which is known for the cybersecurity community. So what we need to ensure is that on its way to the cloud, the data is duly protected by some processing. And the approach we are going to present you is that since we cannot do lots of computation at the IoT side, we have to group together the information to provide a sort of differential privacy for some groups of the data that is being sent on the fly. And then by means of the secure multi-party computation, we provide the necessary protection. So in this case, we consider the structure, the formal layer, the formal structure as a set of layers. At the bottom is the IoT and the IoT applications that are mounted on the IoT, which are producing then this avalanche of data. And the data has to move through the cloud by preserving privacy, and of course, preserving trust. And what can we do is to introduce some edge and fog layers. At each layer, the data privacy will be grouped and pre-processed so that at each layer, we can grant some adequate protection for the lower layer. This means we need to bring together the cloud fog and networking infrastructures in a way that is as simple as possible. For this, of course, we need to conjugate the resource allocation and scaling problem. We need to take into account the service management, of course, the energy consumption, and preserving the data locality, and how this all goes together. So the differential privacy paradigm that we are we have in mind is then exactly at the opposite side of the standard assumption for the IoT. The standard assumption, each device sends its data to a trusted data aggregator. And if I have enough computing power, then I can perform a computation with us, preserving security. But this is the trusted database. In between, we have different layers, and the most useful information theoretic approach would be that at the IoT side, we introduce some local noise addition so that the server can be considered untrusted. And then at each level, the data is being protected and then can go the way up to the cloud without problems. So what are the principles that we have in mind in bringing the privacy to the edge is that the IoT devices are grouped either statically or dynamically. This means there is a sort of obfuscation of the data here, that this travels only after the data has been aggregated by using an implementation of the multi-party computation at the IoT side. So each group of IoT devices send this to the edge, and the information is grouped according to some criteria, which is changing, so it is dynamic. And then by using MPC again, we can transport it to the fog, and then after using MPC, we can send the aggregate data into the server, which will produce the information required by the user by preserving at each step the necessary protection of the security and security of the data and the privacy. So we claim that the edge and fog computing hierarchy can be brought together with secure multi-party computation in order to preserve the integrity, anonymity, and data privacy in general for further processing at the cloud. So our assumption is that the IoT devices are grouped either statically or dynamically, and they are considered as data generators for a specific application or user query. So at the IoT side, we have the challenge to aggregate the data from the IoT, then produce an appropriate secure multi-party computation, and the transfer to the fog and edge. So this is the problems we have to solve. At the fog and edge side, we have to aggregate the data again use the secure multi-party computation, and then transfer either to the cloud for further processing or to the user with the results that were obtained. So in order to fix this idea into our heads, consider a pandemic scenario in which a single user would like to know whether it is safe or not to go into certain parts of the city. So his environment is producing data. He has his own, say, medical records and data, which can be transported to the edge, which is normally a sensitive information. If he has some disease, if he has some health parameters that can be part of a warning sign, then this information is sensitive, and in order to exclude discrimination, this data has to absolutely be protected. So the user, in order to know if it is safe or not to go to a certain part of the city, he will request the data from the environment, but it will provide also with his own data, which is sensitive. And then once this interchange has been produced, he can receive, for example, visual information upon the risk assessment for the region in which we want to travel. So say a risk map. What does the environment? The environment captures the sensitive data of the individual users and groups that so that no individual user can be recognized alone by the data that has been transmitted. For this, we need secure multi-party computation for differential privacy. And then once this has been done, it can be forwarded to the edge and cloud. And then once it is in the cloud with enough computing power, the risk assessment can be obtained. And then the environment get this assessment and transmit the data to all the users in a secure manner. So for this, we need all the tools that we have in fog computing for IoT, cloudlets, micro data centers, fog nodes, and so forth. We need strong randomization of data with secure multi-party computation, which we are investigating. And we need to measure the impact upon the resource usage adequacy, because we have an increased communication. All of this happens with increased communication. The data randomization needs, of course, a source of randomness, which means that the overall data needs to adapt to a large scale. So large scale IoT has to be taken into account. And then once this has been done, we need to deploy a multi-party system as a service. So this is how do we get to that. For the pilot and validation, we need to get an estimation of the performance we expect to get. So resource allocation will be studied by us, the communication overhead. We need to assess the performance of the protocols in a real-world scenario. The pandemic is a welcome example for this. And then we need to assess then the secure multi-party computation at the edge. And of course, introduce some optimization algorithms for dynamic grouping. And of course, obtain all the metrics and analysis of this networking. Not last but not least, the power consumption of devices using secure multi-party computation has to be estimated also. And we have to model the inputs and outputs for the multi-party computation at the edge, which of course is key for the evaluation of the efficiency and limitations of this proposal. So this research, as I told you before, is partially funded by the Sao Paulo Research Foundation, the FAPESP, and the CNPq, the Brazil, and from Universidad La Frontera, the Vicerrectoria of Investigation, with grant 0060 of the year 2020. So thank you very much again for this possibility of presenting you these results and this investigation. This is an exciting subject, and I look forward to continue this research with my colleagues in Brazil and France. So thank you very much.